Hello, this is section 3.4. We're going to talk about linear programming, which is a continuation of what we have been working on. We've been working on graphing linear systems, and we've been mostly focusing on two inequalities. So you'll notice when we do our examples, maybe you have three now, or maybe even four inequalities. So you have a larger system. You're still going to graph, you're still going to shade, still going to find that shaded section. And then with our linear program, there'll be one additional step at the end. All right. On page 157 in your textbook, there's a few definitions highlighted there. I would strongly recommend you take a look at those as well. You may hear me use some of that vocabulary, and on that page 157 is where you can find those definitions. All right. So I'm just going to work through two examples here for you. In example one should look very much like your previous homework. Like I said, though, this time we have three different inequalities here that we're going to graph and shade. So we have x plus y less than or equal to 6. We have x equals 0, or x greater than or equal to 0, and y greater than or equal to 0. All right. So again, similar to before, you're just going to graph them one at a time. Make sure they're in slope-intercept form. Okay, so in this case, I can see where you're going to have to do a little work on that first inequality. Typically, when I'm doing these, if I see equations or inequalities like these two, or something like this, if you have those vertical and horizontal lines, I usually do those first just to kind of get them out of the way. So we're going to do that first. In problem number one, so I'm going to take a look at these two right here. A lot of times in linear programming, you'll see that x is greater than or equal to 0 and y is greater than or equal to 0. All right. And if you see those together, basically what that means is everything has to be in quadrant 1. All right. So if x is greater than or equal to 0, okay, so this would be x is 0 right here. Greater than means it has to be everything over here. All right. When it says y is greater than 0, okay, this is y would be equal to 0. That means it has to be everything above there. Okay, so if you ever see this, x greater than or equal to 0, y greater than or equal to 0, you know that you always have to stay in quadrant 1. All right, so I'm not going to shade anything yet because otherwise I'm not going to be able to see any of my lines. All right, so we're just going to remember that everything right now has to be in quadrant 1. All right, so we're going to go ahead and we're going to take a look at this inequality here. We have x plus y less than or equal to 6. All right, so we do have to do one tiny little thing to get this into slope-intercept form. We need to get this x over to the other side of the inequality. So if I need this over there, I'm going to subtract it to the other side, which means I would have y less than or equal to, I'm going to put the negative x in the front, and then plus 6. So this is the line that we are going to graph right here. All right. So using our slope-intercept form, we see the 6 at the end here. This is going to be my y-intercept. There's a negative sign in front of my x. So if you wanted to, we could squeeze in a little 1 over 1. So my slope would be negative 1 over 1. All right, so let's go ahead and get that on here. So I'm going to count up to 6. 1, 2, 3, 4, 5, 6. So I'm going to put my point there. I'm going to go ahead and count my slope. So from my 6, we're going to go down 1 to the right, down 1 to the right. And again, similar to the last ones, I usually keep on going a couple times to make sure I can get a nice straight line. It says less than or equal to, so I can make it solid. All right. All right, so now I'm going to go ahead and we're going to shade. This says less than or equal to. So that means, here's my line right here, less than or equal to means I need to be below the line. Okay, now if you remember what we said about these two, I still have to be in quadrant 1. Okay, so I need to be below the line, but still in quadrant 1. Okay, so if I stay in quadrant 1, okay, I'm going to be here, and I need to go below the line. Okay, so I'd be everything in this section right here. Okay, and this in linear programming is what we call the feasible region. Okay, which means again, all my solutions must fall in this shaded feasible region. Okay. One of the important things that we're also going to talk about when we do our linear programming is you'll notice you kind of get this little shape here. In this case, it's a triangle. Sometimes it might be a square, rectangle, trapezoid, whatever, that shaded feasible region. And one of the things that we're going to be paying attention to is the corners of that feasible region. Okay, we call those the vertices. Sometimes we call those the critical points. Okay, so you need to make sure that when you're making your graph, again, please use your graph paper. Make sure you draw nice straight lines because we're going to be looking for those ordered pairs that make up the vertices of the feasible region. All right, so again, nothing really new in that section there. Graph, shade, find that shaded area. All right. Okay, now on the second one, we're going to go ahead and we're going to kind of add on, like I said, the little extra part. You're still going to start off the same way. Take a look at your inequalities, do your graphing and shading. We're going to look for that feasible region, like I just talked about. We're going to look for the vertices, critical points. And then I'm going to talk to you like what you do with that. All right. So here for problem number 2, we do have x is greater than 0 or equal to, y greater than or equal to 2. Okay, and then we have 3y less than or equal to negative 2x plus 12. All right, so again, I'm going to start with these two. Like I said, I usually start, a lot of times you'll see they have those like vertical and horizontal lines. So those are kind of easy ones to start with. So again, x is greater than 0. Okay, so again, if I go, this is my x-axis here. If I were to go to 0, okay, that would be a vertical line through 0 would look like that. Greater than, again, means I have to be over here in either quadrant 1 or 4. Okay, sometimes when I'm doing these, rather than coloring the whole graph and not being able to see anything, I draw like little, I'm going to draw a little arrow. Okay, so I need to shade greater than. So I'm going to put that little arrow there, knowing that I have to say over on this side. All right, if we graph this one, y greater than or equal to 2. Okay, so I'm going to go to my y-axis. We're going to go to the 2, put our point. And again, this is a horizontal line. So I'm going to go ahead, I'm going to draw my horizontal line through the 2. Okay, again, make it nice and long. You don't know where the other parts of the graph are going to be. It would look like that. And again, as far as my shading, and like I said, I'm not going to shade yet. I'm just going to think about it. I would need to shade above that line. Okay, so again, here's my line. I need to shade above. So again, I'm going to put a little arrow over here to remind myself. I need to shade above that line. Okay, now let's go ahead and graph our third one. So we have 3y less than or equal to negative 2x plus 12. We do have one tiny little step. Again, to get it in slope-intercept form, we need to get rid of this little 3 here. So we're going to go ahead and we're going to divide everything by 3. All right. So we would have y less than or equal to negative 2/3 x, and then that would be plus 4. All right, so there's my last inequality. Slope-intercept form, again, my intercept is 4. So 1, 2, 3, 4. Sometimes when you're graphing a bunch of lines, make sure you always go back to the origin. Sometimes you see this and you start counting from here. Make sure you go back here. So from here, I went up 4. My slope is negative 2/3. So I'm going to go down 2 over 3. Down 2, 1, 2, 3. Right, down 2, 1, 2, 3. And again, since it's negative, just kind of double check. Remember, negative, your slope should be going downward. If it's not, then we did something wrong in our counting. All right, so we got that. All right, now where's the shaded feasible region? So we need to be below that line. All right, so if you look at all my little arrows here, okay, so this is my x greater than 0, okay, and we had to be to the right. This is my y greater than 2, which means I need to be above, okay? So we need to be to the right, we need to be above. And my last inequality said less than. So in this line here, I need to be less than, all right? So the little feasible region is going to be this little tiny triangle that you see right here, because it has to be to the right of my vertical, has to be above the one where it says y equals 2, greater than or equal to 2, and I had to be below my slanted line. All right, so this little section right here would be my feasible region. All right, so now the last step I want to talk about, and this will be the new part, okay? A lot of times when you're doing linear programming, we have what we call an objective function, okay? This is not a function you have to graph, okay? This is a function used usually in business for things like that, to find like maximum and minimum. So like you usually want to maximize your profit, you want to minimize your cost, okay? So you will have what's called an objective function. A lot of times you'll see the variable P for profit or C for cost, or maybe they just have some random variable there, but that's an objective function. You do not have to graph this function, okay? So if you see that, don't graph it, just hang on to it till you get way to the end. All right, so the max or min of the profit function is always going to happen at one of the vertices of that feasible region, okay? So in our graph that we just did here, this little triangle is our feasible region. So the first thing you're going to want to do is you're going to go ahead and you're going to write down the vertices, okay? You're going to write them down as an ordered pair, okay? So looking at my graph, okay, this is one of my vertices here. Its ordered pair would be 0, 2. Okay. Another vertice would be here. That would be 0, 4. Okay. And my third vertice would be right here. And that is 1, 2, 3, 2. Okay. So these are my vertices. Again, the first number in the ordered pair is the X. The second number in the ordered pair is the Y. All right. So what you're going to do is you're going to take those coordinates from your vertices, kind of one at a time, and you're going to substitute them into the objective function that you were given. The X value would go in here, the Y value will go in here. Okay, so if this was, I'm going to say P for profit, if this was a profit function, I would take 18 times X plus 12 times Y. All right, get my calculator out here in case I need it. All right, so X coordinate, Y coordinate. Okay, so I'm going to plug them in. I'm going to go ahead and write it down. So we would take 18 times 0 plus 2 times 12. All right, so that would be 0. That would be 24. All right, and then you go ahead and we do the next one. This is my X coordinate, my Y coordinate. So we would have 18 times 0 plus 4 times 12. Okay, so again, that would just be 0. And 4 times 12, 48. All right. And then my last ordered pair, we have 3 and 2. We're going to take 18 times 3 plus 2, or 2 times 12. All right. So 18 times 3 plus 2 times 12. Okay, and that would be 78. Okay, and again, sometimes they might be asking you for the max, or sometimes they'll be asking you for the min. So max means the biggest number that you got, min means the smallest number that you got. For this particular problem, it says maximize. So again, this is, like I said, probably a profit. I want to make the most money. So if I was wanting to maximize my profit, which one of these vertices would give me the maximum number? All right, so you can see here we got a 24, 48, and a 78. So this one here would be my max. Okay, so that means the maximum would occur when my vertice was 3, 2. All right, so that's what you're going to be doing on your assignment. For some of the questions, they will just ask you to graph and shade. So again, please read the directions. So it may just be something like my first example here, where you have several inequalities, again, probably more than 2 from the other day. You graph all 3 of them. might have 4, but 3 or 4 of your inequalities. And again, your goal is looking for that feasible region. All right. And then there will be at least 1 or 2 where they will ask you to find the max or min. So again, pay attention to the question: maximum looking for the biggest, minimum looking for the smallest. Again, the objective function, which is this one right here. Again, you do not have to graph that one. Okay, the objective function is where you're going to substitute in those vertices, okay, of the feasible region that you found in your graph. All right, so good luck. Let me know if you have any questions.